In this video we're going to start looking at the layout editor that's in our electric EDA. So go ahead and run up the tool. Whenever you've got the tool open, your page should look like this. Now make sure that you're sitting on the Explorer tab here. So when you're in that Explorer tab, what we're going to do is we're going to create a cell. So click on cell and we'll go in and we can put new cell. And it's quite small here, but I think you can just about see it. So give the cell a name. I'm going to call this TMP and make sure it's on the layout option here. OK this. And you'll see that whenever we begin, we've got the TMP cell and you can see it's a layout. Now what we can do is we can get into components, and we want to, in this video, talk through this set of components that we have. So you'll note here that whenever we click on each of these, you'll see they get highlighted. Now there's another thing to note here as well, that whenever we click on them, it actually shows you what they are at the bottom of the screen. Now again, it's a bit small here, but you should be able to see it in your screen here. So if you look at this little box down here, whenever we select a component, it'll tell you what it is. So let's go on here. First of all, we click on there and it actually says metal 4. Now we can come down here and this one says metal 3, metal 2, and this one says metal 1. So these are the metal layers. Remember, whenever we ran this up at first, we had an option to choosing the number of metal layers, and we chose 4 metal layers. So the blue one here is metal 1, so that's going to be down at the bottom, if you like, of our sandwich structure. And then what we would have is, we would have a layer of oxide, which is just an insulating layer above the top of that. And then on top of that, we would have the next metal layer, which would be our metal 2. And then on top of that, we would have an oxide or an insulating layer, and we'd have our metal 3, oxide insulating layer, then metal 4. So we're going to have this sandwich structure between these metal layers. Now the reason we're having these metal layers is that it makes the routing of our devices a lot simpler. So if, for example, you've got hundreds of millions of transistors and you want to connect them together, it means that the routing is really going to be very difficult. So you want to have as many of these metal layers as you can in order to make the routing simpler. So we'll get into that just in a minute anyway. So these are our metal layers here. Now we've also got, next to them, we see here we've got the pins. So we can collect on, say for example, this one here. This is going to be a pin for our metal 3. So if we were to lay this pin down, it means that when we left click and right click, we could actually draw out the metal layer, okay, the metal. So again, we just left click and we right click. So that's us drawing this metal 3 layer. So I'll delete that just now. You can see we've got a pin here as well for each of them. So that's a pin for the metal 4. Okay, so that just gives us access to be able to actually draw, because if I didn't have these pins, then we couldn't draw anything down on the screen. So that's our metal 4, 3, 2 and 1, and that's the pins which allow us to draw out the metal 4, 3, 2 and 1. So that's this little block here. That's quite straightforward. Now we're also going to have another couple of layers that we're interested in, and those are the polysilicon layers. So there's actually 2 of them in this process. So there's a poly 2 and a poly 1. Okay, so these are the connections onto the polysilicon gate. So for example, this one here would be a connection onto the gate of our transistor, and we've got 2 options here. And again, we've got the 2 pins here for this. Now we'll also have to be able to connect between these layers, because we're going to have to go between the metal 4 to metal 3 to metal 2 to metal 1, and finally down onto the polysilicon. So this is going to be these blocks here. So if you click on that, you'll see it says metal 3 to metal 4, and it's a contact. So this is sometimes called a via, that's VIA. So that's the connection between metal 4 to 3, and that'll be from 3 to 2, and that's going to be from 2 to 1. And we've also got a via here from our metal 1 down to the polysilicon 1 and 2. Okay, so that's the connection from metal 1, that's the blue one here, down into these two layers. So all of what we see here are just the different layers and then the vias or the contacts that we can use in order to get between the different layers. So let's just draw this out so that you're sure about it. So we can put down the different vias. So we click on that one. So that's metal 4 to 3, and that's metal 3 to 2, and metal 2 to 1. And we can also put down this connection here, which is going to be the connection onto the metal 1 down to the polysilicon, which would be the gate. So that's another one here. So let's go and we'll connect these up. So if we were to connect the left click here and then right click, you see that we've got the pink one here. So that there is going to be the metal 2. And if I left click here and I right click here, you can see we've got a connection onto the metal 1. And we can left click and right click that across to that point here. And we can left click again and right click. So this is going to go from the metal 2 to the metal 3. And finally this one here. In order to get this one, sometimes you have to actually click on this here. So the actual layer. So this is the metal 4. So if I left click and right click, left click, right click. So we're actually on metal 4. So we've gone from metal 4 down through the via to metal 3 to metal 2 to metal 1. And then eventually this will come all the way down to the actual polysilicon. So left click and I'd have to delete it. So we can actually get down to the polysilicon here. So that's a polysilicon there. We can left click and right click. So don't get confused, although they look similar, that's actually a dark pink and that's a light pink. So those are actually different layers. Of course, in the tool, you can go ahead and you can change the color scheme if you want. So let's go ahead and we'll just drop down into the, well, before we do that, we'll just draw a few wires in. So you might have a wire from here to here, to here, to here, and we might have one for there, left click, right click, and then the left click, right click. Okay, so we'll just draw a few random wires round about. And if you go down now to Window and go to 3D View, click on that Window 3D View. And we've got the actual 3D view. So you can see here that we've actually, you can see the metal 4, we've got a via that goes down through onto metal 3, another via onto metal 2, and then another via down onto metal 1. And this via here comes down and it goes on to the polysilicon gate. Okay, so that's us covered really what we have in this section here. So let's go ahead and we'll go and we'll look at the bottom section. So that's us talked about all of this lot here. Okay, so we've got the different layers that we can get access to, and we've got the contacts which allow us to draw those layers on the screen, and we've got the vias which allow us to contact between these different layers. We're going to cover this little section here now. So you can see that this lot here is similar to this one here. Okay, so we've got in this here an active region. So we've got an N-active and a P-active region. Now, the process here that it's using is a twin well process. So for example, if we have an NMOS device, then the NMOS device exists in a large P well. Or if we have a PMOS device, it exists in a large N well. So let's go and have a quick look at that just now. So here is our NMOS device and here is our PMOS device. Our NMOS has got an N-type source and drain. The PMOS has got a P-type source and drain. Now in order to generate these, this is called a twin well process or a twin tub process. So the NMOS device is going to exist in a large well of P-type material. So we would dope the substrate with a P-type material. So that would be called a P well. So this is going to be our P-type. Okay. Now the PMOS device, it's going to sit in a large N well. So we draw the well here, and that's going to be our N well. So that's an N-type material, and of course the whole lot is going to sit within our actual substrate. So that's our substrate here. So this is our bulk connection, this is our substrate. So it's called a twin well device because all of the NMOS devices sit in a P well, and all the PMOS devices all sit in an N well. Now another thing to note here is that this area here, which is really the source, which is the N-type, the drain, and also the channel between them, this whole area is something called the active region. So we'll go back and we'll have a look at the actual design of our transistor and our electric EDA tool, and we'll look at these areas here, the active region. So that's the active region for our NMOS, and here's the active region for our PMOS device. And we'll also look at the actual well. And of course, we're going to have contacts down onto this well and also down onto this well. So let's go and we'll have a look at those now. So we said that an NMOS device will exist in a P well and a PMOS device will exist in an N well. This is our twin well process. So if you clicked on this one here, you'll see down the bottom it actually says N active. So the little green line there is the actual active region. So in effect this is going to be the source or the drain. And also the active region is the channel between the source and the drain. So it says it's an N active, so it means that this in effect is going to be an N, the N source or the N drain of our NMOS device. So it has to exist, as we said, in a P well. So the dashed line here, or the line here in brown, that's going to be our P well. Now in this instance here, we've got options here. You can look at the N active by itself, or you can look at which is the green, or you can look at the N well, which is the actual well, and it's the hashed lines here. I've also got the pin here, which when we set the pin down, it allows us to draw out this active and the well region. And we've also got both of them together. So if we click on this one here, so this is the one we're actually going to be using, and we can pop that down, and it's going to give us the active region here. So that's a connection down through to the active region, okay? And we're going to have the well here. So if I was to, let's say, left click and say right click here, we're going to have the actual active region. And again at the top here, we could go through to the metal 1, we could left click and right click. So this is a connection from metal 1 here down into the active region. So let's go and we'll have a wee look at that in the 3D window. 3D view. So that's in the 3D view. So all we've got here is a large well. Okay, so it's an N-type material here. So this will be a large P well. And this will be doped with N-type. And we've actually got a contact here from this active region out onto the metal 1. So this would be in effect like a contact onto what could be a source or a drain. So we can do the same with the P active. So these three here are just the same as these, but they're for the P active. So if I click on this and drag it across, and we'll left click and right click, and you can see that we've got the P active region. So this is a P type doped area, and it has to sit in an N well. So this is going to be the N well here round about it. And you can see here the N well has got lots of little dots, okay, and the P well has got the lines across it. So again, we've got the via here, which is a contact from metal 1 down into this active region. So again, this could be the source and the drain, but it would be the source and drain for a PMOS device, as opposed to this here, which would be used to create the source or drain for an NMOS device. Now these two here are contacts onto the P well and the N well. So if you see it in here, this here is a contact onto the active region, and that's a contact onto the active region. We want actually to get a contact onto the well. So that's the well here and the well here. So that's these here. So if I click on this and it says P well, you click on it, it says P well contact. So this is going to be a contact onto this P well here. And you'll see when we drop it down, you can see that we've actually got this same lines running across. So this is the actual well here. So we can take this here and we can create a contact down onto this region here. Okay, and the same goes for the N well. We can take this and we can contact down onto the N well here. So finally we've got the three at the bottom here. So if you click on the one at the left, it says NPN. So this is an NPN transistor, which will be a bipolar transistor, and we're not interested in this one. We're only interested in the NMOS and the PMOS. So if we click on the PMOS, we can put it down at the top, and we can click on the NMOS and we can put that down at the bottom. So the NMOS one here in the bottom, it's going to have an NMOS device has to exist in a P well. So this is a P well on the outside here, which are the crossed lines. We're going to have the active region. So in effect, this is the area between the source and the drain. Okay, so this will be the area that will sit underneath the oxide layer and the gate. And this is the gate here, which is in pink. Now for the PMOS device, we're going to have a PMOS existing in an N well. So this is the N well on the outside, and it's all little dots, okay? And we've got the active region here, again, which will be the area underneath the gate, and this is the gate here in pink. So let's finish off by building up our little NMOS and our PMOS transistors. So we've got our NMOS transistor here, we've got our active region, we've got our gate, and we've got our P well. So what we'll do first of all is we'll click on it and we'll do Control J. Control J turns it around this orientation. Now what we have to do is we have to get access to the active region. So to get access to the active region, we're going to have the contact. So there's the N active. So it's an NMOS device, so we need to get an N active connection. So you can see here that you see the well is a P well, and it runs in this direction, all the little lines. So we'll just leave that there for the moment, and then we can grab another one of these and we'll put it to the other side. Now what we have to do is we can left click here and right click. So that's going to join the active regions together. So in effect this will come down, will be either the source or drain, and that will be the source or drain, and we're going to have the gate here, which are going to control the flow of current along this direction. So again, we'll left click here and right click. Now a neat little thing you can do here is to make it a small size. If you grab everything and you go to Tools and you can go to Compaction, and it will say do compaction, and there we go. That's us. If I take this out of the way, that's us generated a little NMOS transistor. So if we do the same up here, we could click on this, we could do Control J. Now in this instance here, we're going to have a PMOS device, so we have to get access to this P active region. So I'm going to have to use this via here. So that's a P active, and we can click on that there, and we can get another one of those and click on and put it that side. Again, we'll have to join up the active region. So left click, right click, left click and right click, and we'll just make it a bit smaller. We'll delete that because it doesn't look too good there. Okay, we'll just come down here. Again, we'll left click and right click. Now again, if we grab this, we can compact it. So Tools, Compaction, and that's us created our little NMOS or PMOS device. Again, it's not very neat. You can fix it yourself and just adjust it so as it's a little bit neater. So that's a little bit better. So let's go ahead and we'll quickly have a look at that in the 3D view so we can understand what the device looks like. So you click on View, Window and 3D Window. So it takes a few seconds for it to render on my machine, but there's the 3D view here. So let's go and have a look at that. And you can see the devices here. So we've got our NMOS and our PMOS device. Now you can't actually see in this window what is the NMOS and what's the PMOS, okay? You'll only be able to see that in the previous view. So in the previous view you can tell which one is the NMOS and the PMOS simply by looking at the well. So we know that the bottom one is the NMOS because it's sitting in a P well. We know the top one is a PMOS because it's sitting in an N well, but it gives you an indication of what the devices look like. So again, we can just pop it there, and it's a bit awkward to see here, but well, you can mess about. But you can see here we're going to have the connection onto metal 1 down through a via onto the active region. So in effect this becomes the, let's say we call that the source, and we're going to have the channel which runs along here underneath the gate contact, and current's going to come out through this via here up onto metal 1 again and head out there. So the current's going to come in here, down through, out through the channel, up and out through this connection, and we can see that it's sitting in a large well. So that's us really learned everything that we need to know about the tool here in terms of the layout. But as we go ahead and build more circuits, it'll become more obvious to you, and you'll become quite proficient at creating these circuits. Now there's a few other things we're going to have to learn about layout, and we'll do that as we work through the rest of the examples in the course. So thank you for listening. I'll get you on the next video. Goodbye.